Large side-to-side differences in front camber can create steering forces that may lead to a pull and cause accelerated tire wear. With the zero camber setting, steering forces are generated from either side, and each wheel rolls straight ahead. But if one wheel is cambered positive on the right side, it tends to roll to the right. Combine this with a left wheel that is negatively cambered, and it generates an even greater steering force that causes the vehicle to move immediately to the right. As a rule, a vehicle will always move to the side with the greatest positive setting. Here are some more examples. To prevent camber pull, manufacturers normally specify the same preferred setting for each side. If this cannot be done, camber should be set so that the side-to-side variance does not exceed the manufacturer's specification. If a cross-camber tolerance is not available, use 0.25 as a rule of thumb. The only exception is when there are separate camber specifications for each side. Various methods are used for camber adjustment depending on manufacturer and the type of suspension used on the vehicle. Short and long arm suspensions are usually adjusted by inserting or removing shims between the upper control arm mounting and the inside of the frame. Increasing the number of shims moves the camber setting to a more negative position, whereas decreasing the number of shims changes the camber toward a more positive position. Shims of equal thickness should be added or removed on both upper control arm mounting bolts to change the camber setting without affecting the caster setting. Other manufacturers use shims between the upper control arm and the outside of the frame. On this type of adjustment, increasing the shim thickness increases positive camber. Yet other manufacturers use eccentric cams on the inner ends of the upper control arms, or cams on the inner ends of the lower control arms for the camber adjustment. On some short and long arm suspensions, an eccentric bushing in the upper end of the steering knuckle is used to adjust camber. On other short and long arm suspensions, an upper ball joint eccentric may be used to adjust camber. Some McPherson strut suspensions have a cam on one of the steering knuckle-to-strut bolts to adjust camber. Aftermarket kits that provide for additional camber adjustment through the steering knuckle-to-strut bolts are available for some McPherson front suspension vehicles. On some McPherson front suspensions, camber is adjustable by moving the upper strut mount inward or outward in their elongated bolt slots. Aftermarket kits that provide for camber adjustment through a slotted plate are available for many McPherson front suspension vehicles that do not have an adjustment provided for by the manufacturer. Always check to make sure the ball joints, upper strut mounts, and engine cradle are not worn or damaged prior to installing an aftermarket camber adjusting kit.